y'all, this is Sarah. I'm back with another video in my Calculus 1 series. Today we're moving on to the idea of limits. We're just going to introduce the general concept of them and then one-sided and two-sided limits. All right. So this example is just going to help us kind of get comfortable with the idea of limits. So we have this graph of a piecewise function over here, and then the definition of that function is over here. So for all, this first condition tells us that when x is not equal to 1, then we have the function x squared minus 1. So everything here and everything here. And then at x equals 1, we have 2. So that's why we have this point and we have a hole here. And what we want to know here is what's the limit as x approaches 1 of f of x. So when we're thinking about this, the idea is basically as we get closer and closer to 1 from the left and from the right, what value are we approaching? And we can see pretty clearly from the graph that this should be 0, but let's plug in some numbers just to make sure. So let's start with coming from the left-hand side, so this arrow here. And we're just going to plug in numbers getting closer and closer to 1. So let's try 0.9. That gets us negative 0.19. And then 0.99, we get negative 0.0199. 0.999, we get negative 0.001999. And then finally 0.999, negative 0.00019999. So clearly from the left-hand side, as we get closer to 1, the function is approaching the value 0. Now let's try some values on the, here, and I'm going to move this over so we have more space. Let's try some values coming from the other direction. And now that's going to mess everything up. Okay. So now we're coming from the positive direction, from the right-hand side. So let's see. So we're going to plug in 1.1, and that's going to get us 0.21. And then getting a little bit closer, right, we're going to plug in 1.01. That gets us 0.0201. Okay, so a little bit closer to 0. And then 1.001, that gets us this number. And then throw in another 0 in there, we get this number. If I even have space to write it. Okay, there we go. So as we can see from both sides, as we approach x equals 1, f of x is approaching the value 0. So even though the value of f of x at 1 is 2, the limit of f of x as x approaches 1 is going to be 0. All right. So that is a two-sided limit, okay? It approaches the same thing on both sides. We also have a concept of one-sided limits. And so if you look at this function, when we're talking about approaching 0, f of x is approaching different things from the left and from the right, right? So from the left here, as we approach 0, we're approaching negative 1 as our value. And from the right, we're approaching 1. So we can write this as two separate one-sided limits. So we write this as the limit as x approaches 0 from the left or from the negative side of g of x equals negative 1. And then the limit as x approaches 0 from the right or from the positive side of g of x equals 1. So because these are different, if we were to try and just write the limit, the two-sided limit as x approaches 0 of g of x, what we would actually get is does not exist. We write that as DNE. And so this leads us to a very important theorem. And basically what this theorem states is that the limit exists and equals a certain value if and only if the one-sided limits exist and equal that value. So here's our two-sided limit going to some arbitrary point A of f of x equals some limit L. if and only if the limit as x approaches a from the left of f of x equals the limit as x approaches a from the right of f of x equals L. So, if these two don't equal each other, then this limit does not exist. All right, so that is just a basic introduction to one-sided and two-sided limits. If you enjoyed this video, please like and subscribe.